Let's take a look at Jada's making this $7 an hour. Who can tell me my two variables? All right, Vinny.
Money, minutes.
Money and time. Time and hours.
My bad.
Okay? Someone else tell me which one of these is going to be our independent variable. Which one's independent, Sean?
Hours.
Yeah, time, which means our money's going to be, yeah, however many hours you work. So she's probably trying to push that sucker slow. She just sipping some tea, walking behind the lawnmower, saying, "More time, more money, baby."
No, she's using a riding mower on
She's-
like the
Oh, right, yeah. That's what she's doing. So we got time per hours, and we got money. Everybody good with our independent variables?
Yeah.
Okay. So who's got an equation for me that we could? So I have a representation as a graph here, kind of. But what equation? Yeah. What's your first name? I got it. Troy? Y equals 7x. Okay, someone else might say something like total money equals $7 an hour. They're the same thing. Sometimes I like putting variables in that like kind of help with the word of the situation, just for organization. So yeah. And then let's put a couple like reference points on here. Who's got an ordered pair that would be on that graph then? And Devin. So 28 hours would be $4?
We swapped, like, we switched.
So you could switch it, but what I would say is the time would probably make more sense being independent of the money. Yeah, 428. Who's got another ordered pair that'd work? Ava. 321. Yeah, and how many points are on this line actually?
700, 100.
Infinite. It could, I mean, kind of. You can't just infinitely mow lawns, but in theory, infinite hours.
Oh,
Yeah. Let's talk about these tanks. I heard Shed's Aquarium. Do you know that there's like talk? John Ball Zoo is trying to get like a legit aquarium downtown. They're trying.
Oh, yeah, I heard.
It'd be like years out at this point, but okay. So
Where would they put it?
here is A, okay, and then B. So which one started out with more water? Who can tell me which one and how they know? JP?
Tank B, because
Tank B? How do you know?
Tank B started with 400. The other one only started with 200.
How do you know the first one started with only 200? Because it didn't even say that.
Because it says 200 plus 8.
Oh, so like after no time, there was 200 in there. Anybody else notice how cool it is? Like an equation can like, you can see a situation with an equation. It's just letters, numbers, and symbols. I think it's really cool. Okay, who can help me write an equation that represents B then, since we don't have one yet? All right, Brandon.
B equals negative 5t plus 400.
Okay, a lot of us probably wrote 400 minus 5t. Same thing. Either way, we're starting with 400, and we're taking away 5 gallons each minute. Okay? Hopefully intentionally, otherwise we got a leak. All right? Number 3, one tank's filling up, other is draining. Who can tell me which one's which and how they know? Zep.
A has addition with positive numbers.
So that one's increasing
Yeah, it's increasing.
by 8 gallons a minute.
It's decreasing because it has subtractions with positive numbers. Because we have negative numbers and they're all good.
Yeah, so this 8 and negative 5.
I mean, it's technically the 400 plus negative 8, but it's also the same thing as taking.
So I've got a positive 8 happening over and over and a negative 5 happening over and over. Do you know the fancy math word for those numbers?
Addition and subtraction. Negative.
So when it looks in the equation like right here and right here, when it's attached to the coefficient like that, in a function it's called the slope.
Oh, yeah. Oh, yeah. Oh, my God.
You might also hear it called rate of change. Same thing.
Yeah.
Okay. So we have another tank, tank C. C is equal to 800 minus 7t. Is this one filling or draining?
Draining.
Draino. And you know it's draining because of what?
Because it has a negative.
Yeah, that slope of negative 7. If I gave you a bunch of these functions, could you tell pretty quickly whether it's draining or filling?
Yeah.
I think you could probably tell pretty quick. Now this graph, what is it? Draining or filling?
That one is draining.
Draining, right? Over time, it's going to be empty.
It's still the same.
Why do you think this only shows one quadrant of the coordinate plane? Coordinate plane has 4. What do you think, Ivy?
Well, just because you can tell the slope is negative just by this.
You can. Why else are we only having the one coordinate plane, Matt?
The water's not going to go to like under.
Yeah, we're not going to have negative time, and we're not going to have negatively filled, right? Yeah. Just something I like to point out, because a lot of these that we see are 4 quadrant coordinate planes. Cool. You guys notice this is a lot like the candle problem? Nope. Oh, maybe. So what I did is, when I checked this out, I knew that after 20 minutes, the shadow was 10.5 centimeters long. Okay? So what I chose to do to get 95 was I did this. I said it was growing 10.5 for every 20 minutes. I multiplied that by the 95, and I got something like 48.9 or something like that. Okay? Cool. But when I looked back, look how off I was to the actual. Right? I gave you the actual. Look how far off that is. That's pretty far off. So then I went back and I said, what's going on here? Well, I noticed my rate of change for the first 20 minutes was about 1/2, 10.5 to 20. But then it went, I got 15.5 change over 40. And if it was closer to half, it'd be closer to 20 over 40. So my rate of change changed, which means, is it linear? Not linear. Which means it does kind of follow a linear model for a portion of time, right? It's like close-ish, but it's not quite linear. The next question is it a function of time, the shadow?
Yes.
What do you guys think? Is the shadow a function of time?
No. Yes.
I've got yeses, I got nos. So the first thing I want to ask is, does it have to have a pattern to be a function? No. A function means at any given time, is there just one shadow length, or would there be more than one shadow length? That's the real question here. So at any given time you measure that shadow, how many lengths would there be? 1, which means function. All right? Any given time, there would only be one measurement to take for length. That means it is a function. To be a function, it doesn't have to be pretty. It could be like this ugly graph as long as there's not 2 outputs for 1 input. So you guys remember this situation from the other day? This is that garbage recycling one. Okay? So it's asking me to sketch a linear model for 1991 to 95. And let me show you what that means. It means I'm going to sketch something like this. I'm going to try to draw a really straight line. Okay, good. And would you agree that that linear model I just sketched is really good, actually? Like, not perfect, but really good for 91 to 95?
Sure.
Yeah. For which year is it good? 91 to 95? Check. It's really good. What would you say for any other years? Is anything else close to that linear model? No. So I'm going to say trash for all other years. That's a pun a little bit. It's not a good linear model for anything except 91 to 95. What I want you to do at your table is make a linear model that works for a chunk of time. Any other chunk of time except the one I did. You can't do 91 to 95. So in the other classes, we came up with like 3 or 4 different linear models for portions of time. That's what I want you to do right now. Just do one. So pick a chunk of time, try to make a good linear model for that chunk of time. Who can explain to me a period of time where they drew a linear model? Brennan?
98 to 09.
Oh, so you went like pretty big like that?
Yeah.
Yeah, I think that's the one I did when I did it on my own. And you could almost go a little earlier, right?
I did too.
These ones right here aren't that far off, but yeah, that one works. Who can tell me a different one that they did? I've got lots of colors here. No, I want wraps. Sorry.
2011 to 2013.
Yeah, check this one out, guys. It trends down right there. That linear model with that negative slope only works right there, right? Okay, let's take one more. I know there could be potentially more. Yeah. 99 to 2015. So you tried to like kind of go like a little lower than that, like
The entire section. 19.
yeah, that kind of works. Something like
That works.
one I saw a couple times that works as well. I saw one like this through there, and I saw one that was like more specifically like up here. It's getting kind of muddled up, but you guys get the idea. There's lots of different little linears that work for certain chunks of time. Is there a good linear model for this whole thing? I don't know. I mean, you could draw something like this, but all of these are pretty far off then, right? So linear models are really good for a lot of things, but not everything does fit in a linear model.